Okay, guys, we're going to start back with the calculator application of finding the percents. So this program on our calculator will calculate these same percents that we have in this table. So it will not be necessary for you to memorize them. I think it's important to see the percentages like we did in the first few examples so that you can understand the symmetry behind it. But the calculator will be able to give us the most precise values. So when I did all of this information, right, what percent of students scored between 120 and 160 and plugged all those values in, I see that 72.5% of my students would have scored between those two values. Okay, so now let's see some other ways we can use our calculator. So we have a practice question. I'm going to ask that you try this on your own, pause the video, and then check your answers with what I have done. So basically what we're going to do is we're going to compare how the normal distribution chart will compare to the calculator. So it says a normal distribution has a mean of 100 and a standard deviation of 10. Right, so that means 110, 120, 130 on that side, 90, 80, and 70 on that side. Find the probability that a value selected at random is in the given interval. So now we're looking at probability, right? What are the chances of taking a number within that section? Well, the percentages directly correspond to how much of my information falls in that section. So if I'm picking at random, I will have this percent as a probability as well. Okay, so if I'm looking to find the probability that I will pick a value between 70 and 130, I am basically looking at what percent of my information falls between 70 and 130. So if we do this using the Bell diagram, right, we find 70, which is 3 standard deviations away from my mean on the lower end, to 130, which is 3 standard deviations above the mean. And I add all of these percents, so 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35, I will get a total percentage of 99.7%. Okay, so 99.7% of my information falls between 70 to 130, which means that I have a 99.7% chance of picking a number between those two values. So now, how do we plug this into our calculator? Let's remember, we press second, and then we press vars, right? We click option number 2, which is normal CDF, right? And the values that we should plug in, my lower would be 70 because that's the lowest value I'm looking at. My upper is 130. My mean is 100. And my standard deviation is 10. Right, so those are the values you should plug into your calculator. And what should appear on your screen is the following. Normal, CDF, 70, comma, 130, comma, 100, comma, 10. So now again, this is required to show your work. Now what pops up when I type that into my calculator? Well, I get 0.9973, which when rounded gives me 99.7%. So there might be a small discrepancy, again, because your calculator is going to be more precise than just visualizing the normal distribution table, but they should be pretty close to one another, the percentages. Okay, so now let's take a look at some more challenging. So we're in the same section, page 744, but now we're looking at 27 and 28, which has a little bit different wording. So we still have a mean of 100, we still have a standard deviation of 10, and we're still finding the probability that a value selected at random is within a given interval. But now we have to look at most 110. Okay, so what does that mean? Well, if I have a normal distribution, to have at most 110, that means when I have 110, at most, that means I'm looking at values below 110. Okay, so the percentages are going to be all the percentages that are added up below the 110. Now, we could do this by hand, but I'm going to stick with my calculator. So now when the calculator comes up, we are not really sure what our lowest bound here. We don't know what the lowest score could be. We don't know if it's 0, negative 100, whatever. So what we have to do is we have to pick a lower bound that is so low that it's impossible for any other numbers to be below it within our data set. So what number I'm going to suggest you plug in is a negative 10, because that's a negative number, to the 99th power. Okay, so that's a number so low that the chances of a value being within that value is slim to none. We're going to choose our upper bound as the 110 because that's the highest value we're looking at. Then we fill in the rest. Mean is 100, standard deviation is 10, and on our screen we should get 0.8413, which gives us approximately 84%. Now you're going to round this 84% to whatever the question asks you. There's no specific here, so I'm going to just round to the nearest whole number for this particular example. Okay, so now 28 is the opposite. Now we're looking for at least 80. So if we think about at least, right, that's the lowest amount that we possibly could want. So if we draw our bell curve and we pick out 80, we're looking for anything that is 80 or above, right? So we would typically add up all of those percentages that are above the 80 mark. So if we're using our calculator, right, now we have a lower bound, but we don't have an upper bound. So we're going to use that same trick just in reverse. So my lower bound here is 80. And my upper bound, I'm going to recommend that you use 10 to the 99th power. Because that's a number so big, the chances of one of our numbers being bigger than that is slim to none. We still have a mean of 100. We still have standard deviation of 10. So when we press enter, we get 9772, which is approximately 97.7%. Okay, so that's another rounding that I chose to do to the 10th spot. So that means 97.7% of my information should fall above the 80 mark. Okay, so the calculator is proving to be pretty useful here with our examples. So let's just take a look at one other calculator application that we have. So this is called the inverse norm, which basically what it does is it reverses, right, the normal distribution. So instead of giving our percentage, it's going to give you the number that is related to that percentage. So I have the definition. It returns the data value when given the percent below the value. So where is this founded? Well, we're still choosing second vars, right, for the that's a distribution menu. But this time, instead of choosing option 2, we are choosing option 3, INV norm, inverse norm. Now, when you choose that, you should see this menu pop up. Now, not everybody will see this right, left, center, but we're going to choose left because we're looking for the percent below the value. So if you do see that, choose left. So let's look at this question to figure out what we've plugged into the inverse norm to get a value. So we're looking at page 744, number 21. To qualify as a contestant in a race, a runner has to be in the fastest 16%. Okay, meaning when you're the fastest, right, we want shorter times. The running times are normally distributed. Okay, that's a key word that we're going to have a bell curve with a mean of 63 and a standard deviation of 4 units. So what is that? 59, 55, 51, right? We are looking that direction of my mean to the smaller values because we're going to be faster. To the nearest minute, what is the qualifying time for the race? So what are we going to do? Well, we want the fastest 16%. So we're looking for the 16%, right? That goes on that side to the left of a value. So when I look at this 16%, I'm going to rewrite it as a decimal, and that value is going to go in the area section. Okay, so what's the area of the 16%? This is still my mean. This is still my standard deviation. And again, we're choosing to the left of a particular percentage. So we'll have that. We press enter. What do we get? Well, now we don't get a percentage. We get a value that has 59 and some decimals. So it's rounded to the nearest minute, so I get 59. And what is this referring to? Well, it's referring to a run time of 59 seconds. Okay, so what is the qualifying time for the race? 59. Everything below that, you get qualified for the race. Okay.